Okay, so I clearly didn't get to finish that last video. I had kids come in and I had to make sure I got to my class. But that makes it more fun this way. Okay, so let's see, we were motorbike and the actual bike. Yeah. Okay. So on these problems, we tend to get the variable t by itself. So like on the top equation, you're going to divide each side by r. That way you get t equals 40 over r. And that 40 over r is going to be really important to us. If I sound like I'm being quiet, it's because I'm at home and my kids are asleep. I don't want to wake them up. So we're going to divide the second one by r minus 20. So we'll do r minus 20 here, r minus 20 here, and then we get t equals 15 over r minus 20. And this 15 over r minus 20 is really important because we're going to set it equal to the 40 over r. So I am going to zoom in as best as I can so I don't go to the next page with my writing. So I'm going to get 40 over r. Oh, I think they just woke up. Equals 15 over r minus 20. Get a common denominator of r separate from r minus 20. And then the bubble step is like, okay, what's each one missing from the denominator? So this one needs r minus 20, and this one needs, let me get my bubble in the right spot, just an r. So we end up getting 40 times r minus 20 equals 15r. When we kind of put like our two, like our purple circles just equal to each other, that's 40r minus 8 with two zeros, so 800. Let's see, I'm going to bring the 15 over by subtracting it, taking the whole term over, not just the 15. That's going to be 25r equals 800. And r is going to equal, let's see, there are 4 quarters in a dollar. So 4 times 8, so 32. And that's miles per hour. And r, let's see, who was r? I got to look at my chart. R was the M. I think in my problem that was about a motorbike. So I can say a motorbike. And then the regular bike was r minus 20. So r minus 20 is just going to be 12. So I can do bike equals 12 miles per hour. And hopefully that matches everything that we got when we did this problem in your homework. And that finishes up chapter 8. So moving into chapter 5. Let's see, this is chapter 5 was on polynomials. We didn't get all the way through, but that's okay. It says put the following into standard form, classify it by degree and number of terms. So to put it into standard form, we would have to distribute and combine. Once we distribute, we get p squared minus 5p plus 6. Nothing gets put together, so that is in standard form. And then you're going to have to go to your 5-1 notes and get that chart. You're more than welcome to take a picture of it and just have it ready for you. Maybe you even have a sheet of paper beside you for your final that has some of the names on it. This is a quadratic, and it has 3 terms, so it's a trinomial. Whoops, sorry, I spelled that wrong. My daughter's awake. You want to say hi in the microphone, sweetie?
Uh, Hi.
There you go. Okay, number 2 says find the zeros, the multiplicity of those zeros, and the relative mins and maxes. So we got to go to the website that does it all, which is in the day 75 folder. I would, if I were you, I'd just have this bookmarked, okay? Let's see. I'm gonna type in my equation. So I have x plus 1 squared and x minus 1. So I have x plus 1 squared. Instead of capital X, I need it to be lowercase x plus 1. And then I have, yeah,
I don't know where my
x minus 1.
Starbucks.
You don't know where your starburst is.
Mm-mm.
I'll help you find it. Don't worry. Can I finish my video though? Okay.
Mm-mm.
Thanks, babe. So you type in your equation, hit find the roots. And so I have roots at 1 and at -1. I'm going to go ahead. And I knew that just based on the equation though, right? We knew this one's going to give us x plus 1 equals 0, x equals negative 1. And you see how it had a power of 2? That means its multiplicity. Multiplicity is 2. We knew that. And then from this parenthesis, we would have got x minus 1 equals 0, x equals 1. It only happens one time. It just had a power of 1 up there. So multiplicity of 1. But we also found that from the website, if you remembered. So it did kind of back us up there. And if we look at the website, we can see at negative 1, it's a parabola. So that's why it happens twice. And then our mins and our maxes, I am going to cheat and just take a quick little screenshot of that so I don't lose it. I guess I can dual screen. I keep forgetting I can dual screen whenever I'm on my lesson, but that's okay. So I'm going to go to my notability. You can just dual screen if you're doing this right now with me. Oh, again, like this is not going to be beneficial if you're not going to the website yourself and practicing it. No, I do have to look at the website. Which one comes first? What do they say? The maximum comes first and then the minimum. So that would mean this point, negative 1, 0 is my max.
Purple.
And this point, Rosie, my daughter wants me to use purple, is my minimum. So 0.333, comma, negative 1.185. That's my minimum. Okay, and let's see what else we have. Oh, solve the following. We did this on the Zoom lesson too, so you guys probably have this exact example. It says solve the following. So this is a perfect cube problem. It's a perfect cube problem because it's a binomial and each one of these are cubes. So the cube root of that is a 5 and an x, and the cube root of this is a 3. That's what goes in your first parentheses. What we're going to do first is we're going to factor it. So in this parenthesis, you put 5x and 3.
Mommy,
Mm-hmm.
that seems like that's the mommy one and that's the smaller like the baby one.
Yeah, like this, the first parentheses, the baby one, and the big one's the mommy one. Yeah, I kind of agree with that one. Okay, guys, so according to my daughter, the baby one, you just put the cube roots, and then the big one is where you put the squares of those cube roots. So if we square this here, this 5x, you get 25x squared. And if you square this, you get a 9. I'm going to erase these circles because it gets overwhelming after a while. And then the middle term are these two baby terms multiplied together. And the signs always have the same pattern. The signs are same, different, plus. If you want to write that, it's same, so a minus, different, and plus. Same, different, plus. Same, opposite, or different. And this one's always a plus. And then you solve each parenthesis. So the first parenthesis, you do 5x minus 3 equals 0. That one's not so bad, right? Add 3, divide by 5. Pause the video if I went too fast. Make sure you can take that in. And then the second parenthesis is the quadratic formula. Now I am going to go quickly through the quadratic formula just because we've done the quadratic formula many, many, many times. But again, pause the video, try it yourself, and then check it with the answer. Opposite b plus or minus square root of b squared minus 4ac all over 2 times a. So it's negative 15 plus or minus square root of. That's going to be a negative inside of there. I think it's negative 300. I am going to double check though because I don't want to do this wrong. So it was 15 squared. I know it would be in parentheses. 15 squared minus 4 times a times c. Oh, wow, negative 675. I was way off. Bad. So negative 675. And then you would have to figure out what perfect square goes into negative 675. And eventually, hopefully, I would pause the video. I certainly cannot force you to pause the video, but I would like you to. You would get 225 times 3. If you're not sure how I did that so fast, for perfect cubes, it's always like 15 squared is 225. That only happens for perfect cubes. So then you do the square root of both of those. So you'll have 225 and a square root and square root of 3. And the reason is because the square root of 225 is 15. It was negative, so you need an I. Negative, you need an I. And then divide everything by 5s. So negative 3 plus or minus 3I, square root of 3, over 10. So you do have 3 answers, just like we've talked about, because it was cubic. This one's real. Whoa. Real. And there's 1 real, and then over here you have your 2 imaginary. Okay, so that's perfect cubes. I wanted to make sure I did a perfect cube problem because I like putting those ones on the final. I always have. And now this one. Set it equal to 0 to begin with. So add x to the fourth, add 12x squared, add x to the fourth, add 12x squared. Please pause the video and rewind, catch up with me. So you get x to the fourth plus 12x squared plus 27 equals 0. I choose to factor this. I am asking that you pause the video and factor this. So pause the video, go ahead. If you're grouping, please group it. If you're a box, please box it. You should end up with an x squared and an x squared, a 3 and a 9, a plus and a plus. And if you went to the website, it's not going to cross the x-axis at all. It doesn't have any real solutions. So you can make a note of that. Doesn't cross. If you did the website, it doesn't cross the x-axis. So there's no real solutions. So we're still going to go through the same steps. Set each parenthesis equal to 0, and then solve. Okay, so take away 3, take the square root to get x by itself, take a square root, use plus and minus. The square root of a negative is an I, and there is nothing that goes into 3. So there's 2 imaginary solutions. Now this one, go through the same steps, please. Take the 9 to the other side, take the square root, because to undo an x squared. When you draw a square root, you must use plus and minus in your answer. The negative is an I, and then we have the square root of 9. There is a square root of 9, right? And the square root of 9 is 3. It's not a square root anymore because the square root of 9 is just 3. All right, last problem from a 5-4. Divide using long or synthetic division. State the quotient and the remainder, and if it is a factor. I will get your milk in 1 second. I have one more problem. Okay. So synthetic division is definitely what I will pick. Okay. And so you set what you're dividing by, set it equal to 0, solve for x, you'll get negative 5 over 2, subtract 5, divide by 2, put that in your little box. Make sure that you're not missing anything, like it goes from a cube to a square to a first power to a constant. So I have everything. I don't need any zeros. As always, drop down the 2 and multiply. Negative 5 halves times 2 is negative 5. Add, oh, that's interesting. Now do negative 5 halves times 2 again, negative 5. Oh no, my pen officially died. Let's see if I can get it again. Nope, I'm going to have to. Negative 5. That makes negative 24. Sorry, my handwriting's messy because my pen died. Let's see, negative 5 halves times negative 24 is going to be a positive 60 because it would be positive 12 times 5. Yep. And I get a remainder. That's my remainder of 0. So they want me to tell the quotient and the remainder, so I can definitely say the remainder is 0. That negative 24 is the constant. That next 2 is my x, and that front 2 is my x squared. So this is the quotient and the remainder. And let's see, what else do I need to do? Oh, if it's a factor. Yes, it's a factor because the remainder is 0. And that finishes up our review of chapter 5.